So in this next lesson, we are going to dive more deeply into points, lines, and planes, and we're going to talk about some postulates and theorems about those items. So one important thing to remember is the difference between a postulate and a theorem. A postulate is something that can't be disproved, so it's taken as fact. Way back in the day, geometrists, people that did geometry, would thought of those things as so obvious that they didn't need to be proved. And so they called those things postulates. Theorems are something that can and must be proven to be true. So you have to either prove that it can't be not true or prove that it is true. And so you can do that in a couple of ways that we'll explore later on in this course and in Math 2 later. But for now, we want to remember that both of these two things, postulates and theorems, hold the same weight. We can use them for everything. It's just a matter of knowing that a postulate is something taken as fact, and it's not because we can't disprove it, while a theorem is something that we must prove before we can use it. Luckily for us, some people did some hard work and proved them for us, so we can use them. So the first postulate says that through any 2 points, there is exactly one, and that is line. And that's pretty obvious because if I draw 2 points over here, I can draw one line through it. And it doesn't matter where my 2 points are, I can always draw a line through exactly one line through those 2 points. The next postulate says that through any 3 non-collinear points, there is exactly one, and that answer will be plane. So when we draw 3 points, I can't draw just one line through it, but they are all going to be contained in one plane, and that's what makes the plane. If 2 points lie in a plane, then the line containing those 2 points lies entirely in the plane as well. So if you have 2 points that are on a plane, then the line also has to be in the plane, because through those 2 points I can draw the line, and the plane has to contain them both. If 2 planes intersect, then their intersection is a line. And again, that should be fairly obvious. So if we think about, I'm just going to draw an easy one here. We have a box, the top and the side of the box. We can see that there's a line that goes between where that intersection is. It can't be a point. It has to be a line. If 2 lines, so now we're looking back to the theorems. So the first theorem says that if 2 lines intersect, then their intersection is exactly 1, and that is going to be a point. And they can't intersect at more than 1 point because then the line wouldn't be going in the same 2 directions. Theorem: given a line and a point that is not on that line, there is exactly 1 plane. And then the next theorem says that if 2 lines intersect, there is exactly 1 plane which contains the 2 lines. So when we think about these questions here, we want to think about, in order to determine a line, what do we have to have? So it's drawing back on those theorems and postulates. So if we want to have a line, then we need at least 2 points. In order to determine a plane, then there are 3 possible answers for that. You either need to have 3 points, 2 intersecting lines, or a line and a point that is not on the line. And that all comes from those postulates and theorems up at the top. Number 3 talks about why does a 3-legged support tripod work better than one with 4 legs. And that's because if you have a 3-legged tripod, even if it's not level, it is all the points are on the ground and it will be sturdy. Thinking about a tripod as the thing that you can put a camera on. You see it a lot with photographers or In construction, they use those, and it has some sort of a look kind of like this, and then you have the camera on top. And so the reason that it's more sturdy is because all 3 points will always be on the ground. So even if it's not a level surface, it will be sturdy and hold itself. But if you have 4 legs, that 4th leg may or may not be on the ground. Think about when you go to a restaurant. They have a 4-legged table. The table is, when they have just you have like the table and it's just got the thing and then you've got the things going down. It's not always sturdy because if that one of those legs is not on the ground, then it's going to kind of tip a little bit. So the tripod would work better because it has all 3 points on the ground at once, whereas the 4th leg may not be on the ground. So with your 3-legged tripod, you have all 3 points on the ground all the time, which makes it very steady. Whereas when you have 4 legs, one of those legs may not be on the ground evenly with the rest of them, which would then make it wobble. So number 4, if 3 non-collinear points determine a plane, how many points determine space? So thinking of space as the thing that's bigger than a plane that contains it all, it would be 4 points would determine the space. How many planes may contain 3 collinear points? So if the points are all on one, or they're all collinear, that means they're all on one line, which would then also mean that they are all on one plane, because you'd have the 3 points and they're all in a line, which makes it have one plane. All right, so now I want you to take a few minutes and I want you to decide whether all of these objects would be a point, a line, or a plane, and then come back here and check your work. So when you're thinking of a star in the sky or a pixel on your computer screen, both of those things would be a point. If you're thinking of the floor of the gym, the top of your school desk, any flat surface, that's going to be a plane. While a line would be an overhead power line or the spine of a book. The spine of a book is a little tricky. It could also kind of be a plane. It's just a thin plane, but we're thinking more of it. It's a line. It's going up and down. And then the same thing with the power line. It's just going across. So when we use symbols to name things, we want to make sure that we're using the correct symbols. Unfortunately, Google Docs will not let you use those symbols, or they don't have that kind of feature on there, so you're going to want to write these down. But the main thing to remember is that when you're trying to say that something is a line, you want to put a line over top of it. If you're saying something is a plane, you want to put kind of like a little mini plane right there in front of it. So a line that contains the point W would be line WZ. Since it's not saying a specific thing, you could also know that you have that theorem that says through any 2 points, you have a line. So you could really have line WX and line WY. 2 points that are collinear with point X. So you do want to make sure that they are actually on the line that is with point X. So that would be point V and point Y. A line that passes through point Y would be, and you could name this a couple of ways. You could say line XV or line BY or line XY. And then obviously all those backwards as well. Because you want the difference between 7 and 9 is this has the line passing through it while this is just containing. So you want to actually see the line here. This one doesn't necessarily have to be seen. Number 10, 2 points coplanar with point Z. So it's going to be any of the points that are in this plane R. So W, V, Y, X are all coplanar with Z. So you would say point W, point Y, point X, point V. Obviously, you don't need to say all of them. They just wanted 2, but your answers will vary there. A point that is not on plane R would be either point T or point U. And then a challenge would be 2 points that are coplanar with point U. So coplanar means that they're going to have to be on the same line as you. So that would be V and T. This next section you're actually going to do in class. So we will do that tomorrow during class. And I will also answer any other questions you have about this at that point as well. I will see you then.